Dear students, welcome to Sia's digital classes. Today's concept is measures of central tendency. So it's an introduction for Unit 3. Now what is central tendency? Let us know. So check it out the definitions. First, to know central tendency, we need to know what are averages. Whenever statistics means or business statistics means, it is all about calculating averages. Now why we'll go to calculate average? Because like some data is there, we need to know what is that actually, like without doing everything into deep, don't no need of checking, but we need to have some idea about the data. Now what is that having an idea? Nothing but average of that data. Like you wrote your sem exams, you want to know your results. Before knowing the results, you have an idea about how you have performed, right? Already you have learned and you wrote by yourself the entire exam, so you will be having an idea about how you wrote the exam or how you may going to get your results. So that idea is nothing but an average thought about what is going to happen. So without actual calculation, we need to know the sequence of the data or what's going on with the data. Like you want to go for a movie, so what you'll do, simply you'll go for a movie and you'll watch out. No, first you'll plan whether which movie you want to go, what are the timing, or what movies are there out in theaters. Like that, we'll have an idea about the movie whatever you want to see. So that idea is nothing but an average. So without having any idea, simply we can't jump to a decision. So and without doing anything to that, if you want to have an idea, that we'll call as an average in the sense, just an idea which represents the entire data. Now simply we'll not go for obtaining that idea. We have some methods that will deal under measures of central tendency. Now central tendency nothing but having an idea about the entire data, a central idea which represents the entire data. So entire data will be focused. Like you have 20 members in a class. So entire 20 members, they wrote the exam, they got the answers. Each and every person, definitely I want to check the results. But before that, like if I want to have an idea how they wrote, simply I'll check it out their overall performance. Like 10 members, how they wrote, I'll be asking them. If they said good ma'am, we wrote very well, so I have an idea that they'll get good marks. Or after obtaining marks also, what I'll do, I'll be asking them how you have done. So let me check your answers, or let me check your results. I'll be saying, I'll check them. So overall, after checking the values, I'll come to know that whether they have performed very well or not, or average performance or good performance. Like that, I'll come to an idea about their performance, right? So that getting an idea about the entire data, that idea we call as central tendency. Now measures of central tendency, measures in the sense different formulas to obtain that average. So we have different types of data actually. Every time the same data like x is equal to 1 2 3 4, like that we don't have, right? In real life many situations we have. In that many situations we have to check it out, how the data is going on. Based on the data we need to pick the formulas so that we can obtain average. So averages, different types we have. Generally in school life or in general studies, average is nothing but simply you'll add up your marks and you divide with overall marks and you'll get the answers, right? So not like that. Every time average means not just taking out your percentages. We have different methods to obtain an average or to have a central idea about the entire data. For that, we have a unit as measures of a central tendency. In the sense, different measures we have to calculate the averages, different averages we have, and different methods to that. So why? Because we have different data itself many ways we have. Like here in our units we have as individual, discrete and continuous cases. So individual type, in the sense just a raw data, like you got some roll numbers and you have your marks. So which subject marks, how they are related, or which semester, that extra information will not have. Just I have a rule number, to that I have some marks. So such a type of data we'll call individual data. Now next data we have discrete type of data. Discrete type of data in the sense we have rule numbers and marks of a particular subject, like as 10 rule number 10 has got some 20 marks, like that. So something related to next, how many times it has repeated, if they give frequencies, if they give, so that is your discrete type of data. So or your names, they'll give some particular names, and that particular girl has how many times they wrote the exam and how many marks they got. Like she wrote, one of the girl wrote 5 different subjects. So for 5 different subjects, she got approximately 20 marks. So 5 x value and frequency value some 20, like that. 2 different values if they get related to, both should be related also, then we'll call as discrete type of data. Now continuous type of data we have. Continuous in the sense class intervals they'll give. So further if you check it out the problem, same, all the same data you will be getting, individual, discrete and continuous. So continuous is nothing but you'll get class intervals like 0 to 10, 10 to 20. So one girl has got marks between 0 to 10. So 0 to 10 means class intervals. So such a type of data we'll consider as continuous. So how many types of data we have? 3 types: individual, discrete and continuous series. So all this series, again we need to calculate its averages. So different methods we have to calculate that averages also. For that we have as measures of central tendency. Now what are actual most important measures of central tendency? Let us discuss. So here is an average definition you have. Average just now I have explained. Overall, to get an idea, we will go for averages. Averages are statistical constants which enable us to comprehend in a single effort the significance of the whole. Nothing but getting an idea for the entire data, which represents the entire data. So one more definition also you have, you can check it out. Now let us go for central tendency. Just now we have explained measures of central tendency. So measures of central tendency refers to the way which describes the values or observations in the central part of the distribution. So to get a central idea, we'll try to get different formulas which are called as averages. So in that we have mainly we have mean, median and mode. So most of you might be heard already what is mean, median, mode. But here actually where it is used, how it is used, for which type of data it is implemented, that all will be learning in this unit. So first is mean. We have mean. Again, I have just now we have explained, no, calculated for individual, discrete and continuous type of series. So all different types of series we have, 3 different types. For that all formulas will be obtaining, that is mean, median, mode. Further we have geometric mean, harmonic mean, different methods we have under mean also. All will be learning in this unit. So for exam point of view, you may get for short type, define what is measures of central tendency, give its uses, like that you may get this question also. Now let us check it out to its characteristics also. So what we have characteristics, first point, it should be simple to understand and easy to compute in nature. In the sense formula should be little bit easier, so that we can understand and we can get good results out of that also. So like that you have first point, like that many points you have, you can follow up, check it out. Second point you have, it should be calculated for all the items given in the series. Suppose if any one value is dropped from the series, then the average value would change. So what they are explaining in the second point, they are telling that all the values you have to consider. Like just now we discussed, if you get marks out of 20 students, as a teacher I need to consider every girl or every student in the class I need to consider, and then I have to check it out, right? Like 20 members are there, definitely I want to know that every student wrote the exam properly or not, whether they are getting proper results or not. Then only that average becomes a good one. Like simply I'll check it out one of the girl and I'll ask that marks, and can I represent that marks to the entire class? No. every girl has to get a good marks, or every girl has to write the exam, whatever they'll get the marks, out of that I need to get an average so that I can represent that for the entire class. So simply with one or two data I can't go on. So second point shows that only we need to consider all the data whatever we have, like 0 to 10 values I have, consider from 0 to 10, then that becomes a good average. So that is your second point. Next, go for the third point. It should not be affected by extreme observations, that is one or more observations is very small or very big in the series. So sometimes what happens, homogeneous series will not be, means same way it will not go on. One will be very least value like 0 or 1 they will start, and the last value maybe in thousands will get. So such a type of data if it is there, it will be affected for the between values. Like if you calculate mean is nothing but average, means overall data will add up, will divided by its total. So in such type what happens, last value is the highest value, right? That highest value, if you add up all these values also, you will not get such a huge value. So if you add and divide the average, anyhow you will get the average, but we can't represent that average for the whole data. So extreme values should not be affected, then that becomes a good average. So that is the point here. Like that we have other points here. Fourth point we have, it should be rigidly defined to get only one meaning. In the sense, formula should be very well taken, like I'll take one formula, you can take one more formula. That is not called as a formula. Formula in the sense, it should be universal, means everybody, you have to use the same formula, same answers everybody should get, then it becomes a rigid one. Rigid in the sense, correct one, proper one, only one you need to consider. So next we have, it should be suitable to carry out further mathematical calculations in order to increase its usage. Means further also we have to utilize that formula to, if you want to make any changes, or if you want to utilize further one more formula you want to get out of that formula. It should be simple and easy way to understand and to calculate. So that is your next point. Mathematically it should be utilized to get further answers. So that is your next point. Now let us take it out one more point. We should have a sampling stability. Sampling stability means that the results obtained from the different samples should not vary from each other. A slight difference might exist in the values of different samples. This all will be explaining whenever samples will come. So samples is nothing but from entire data we'll drag some of the part, like 1,000 of students I have in my class. I can't just go on taking each and everybody's result out of that, but I need to represent some average for the entire students. So how to do that? What I'll do is, I'll select some, like 1,000 students are there, from that some 100 students I'll select. So that is called as sample. So we can do that method also. I'll calculate for that 100 members, I'll calculate my average, which I can represent that for the entire students, 1,000 students. So that is one of the methods we have, sampling we call. So such a type of samples if I drag, still it should represent the entire data they are telling here, because I'm not considering all the data, right? Like in second point we discussed, all the items if you consider will get good answers. Yes, obviously all values if you consider, exact answers we can get, so that we can represent. But sometimes what happens, we can't get entire data together, like in lakhs of data we have. In such cases I can't proceed with each and every value. Definitely I need to get some samples. So while dragging samples we have to be careful. Draw the samples in such a way that it should represent the entire data when you go for making averages, right? So like that if you drag, you will get good results out of it. So these are the some characteristics of central tendency. If you follow up all this, we'll get a good average, good representation of the data. That's what it means. So this is how it will go on. Now just now I said in central tendency most important methods are mean, median, mode, right? Now let us have a little glance on that definitions also. In the entire unit we'll be discussing this only. So let us glance the definitions also here. So for first definition we have mean. Mean is nothing but the most used average. So in schooling whatever you have done till now, whatever the percentages you have done, that is nothing but mean itself. So having an idea, having an average idea about any data, that is nothing but mean itself. So in statistic particularly we'll take some formula, we'll call it as mean, and we'll apply to each and every individual discrete continuous case, and we'll obtain the values, average itself, but in a different formulas based on the particular data. So mean refers to average which is obtained by dividing sum of collection or results of an experiment with the total number of collection. The same what we have discussed. Add up all the values in the given data divided by total. How many are there? You divide it, get the answer for mean. So whatever we discussed earlier, the same mean means generalized average itself. So different types also we have to that. That is arithmetic mean, geometric mean, harmonic mean. In further classes, we'll be discussing all this also. Now let us go for median. So median means just obtaining the mid value is nothing but median. So whenever data we have like equal nearby data, like students in a class, like degree second year students, BCom second year students, if you consider, all are of equal range, means they wrote sem1 and sem2, then now they are in sem3, so second year, so everybody wrote the exams of sem1 sem2, so everybody are in the same stream, so almost the same knowledge they have about statistics or other subjects. So we call such data as homogeneous data. Nearby, if I conduct some exam, knowledge whatever they have, nearby they have, because all are in the same standard. So like that data if I have, so no need of going to obtain mean, like each and everybody marks I have to consider, divide by its total, no need, because all are in same range. I know how they'll perform if I conduct the test. Like I have explained some concept for them. Recently I have explained, I want to conduct an exam. Just now I explained, no, so they have almost equal knowledge. So simply what I do is, without going for mean, simply I'll pick middle of the person as in my average, because everybody are in the same stream. Like one more real life exam, if you want to consider, some singers are there. So some 10 singers are there in the room, all are of in the same pitch, like everybody are good at their knowledge. So what I want to pick some of them. So why to check for each and everyone? I know already that 10 members are singers. So simply what I do, from the middle I'll pick one of the person. So this is how median is useful. That is also average itself. So all are in homogeneous way, simply consider in between one of them. So that is how median is useful. Now let us go for mode. So mode is also an average to which represents the entire data. Now where is mode used and what is mode? Let us check it out. Mode is nothing but, mode is the value which has maximum frequency. Nothing but highest value in the data is considered as mode. Median, middle value we consider, right? Mode, highest value. Now where it is utilized, highest value means like in the data many values are there. From that simply highest value if you consider, like you have again, if same example, if you take number of students, some 20 students are there in the class, and everybody has got some marks. So in that the highest marks those who have got will be the first ranker, right? So I can take that particular information or that particular student's marks, that that can represent the entire data, because she is the topper, means she has learned everything very well, she knows entire concepts whatever we discussed. For that only she have performed very well in the exam and she got good marks out of that. So I can take that marks to represent my entire data. So such a type of data where it is useful to take the highest values to represent the entire data, then I'll go for obtaining mode. So based on the situation, based on the data, we'll go for obtaining averages. So mode is utilized when highest value we can represent for the entire data. At that time we'll go for obtaining mode. So this is how measures of central tendency will go on. Nothing but all are about obtaining averages itself, but based on the data, based on the problem, we'll shift to different averages, that is a mean or median or mode. Entire data is important, then go for mean. Every data values will consider there and we'll get the answer. So to represent the entire values, so mean is useful, like entire data is important. Then median, homogeneous data means every data is almost nearby. You can pick any, so simply from the middle you will pick the value, that becomes your median. Then mode, if highest value can be represented for the entire data, then we'll go for obtaining mode. So this is all about measures of central tendency. So to pick an average, we have different methods that all will consider as central tendency. So hope you have understood this session. See you all in the next session. Thank you.